In this section, we'll be talking about conversions from the U.S. customary system to metric system, and from the metric system to the U.S. customary system. I will tell you this, though, that in terms of conversions, you want to minimize conversions as much as possible and work all together in one system or the other system if possible. When you absolutely have to go through the conversion process. And it's really important to know when to do that. And a good illustration of that idea is a situation that occurred at NASA in 1999. You may recall that there was a Mars orbiter worth over $100 million that was lost because one group of scientists were dealing in the metric system and the other group of scientists were dealing in U.S. customary units. One was making calculations in kilometers and the other in miles, and they didn't jive, and so there was a crash. So it's important to either stay with one system or another or be very careful with the conversions. Anyway, we have conversion factors here that we're going to use in the process. And these are not numbers that you're going to be likely to remember, so we're going to just refer to this chart as we go along with our conversions. But 1 inch is approximately 2.54 centimeters. 1 meter is 3.28 feet. 1 meter is also 1.09 yards. 1 mile is 1.61 kilometers. And on we go with units of weight. 1 ounce is 28.35 grams, 1 pound is 454 grams, 1 kilogram is 2.2 pounds, and in units of capacity, 1 liter is 1.06 quarts, and 1 gallon is 3.79 liters. Now you may notice from the chart here, as we move up here to this problem, you may notice in the chart that it's not always the case that the metric units are on the left and the English units are on the right or vice versa. They're just all over the place. Here's how we go about thinking through problems of conversion. If we want to convert 55 miles into some number of kilometers, we're using this rate idea, and it works like this. We think of 55 miles as 55 miles times a fraction which has miles in the denominator and kilometers in the numerator. Now that's the important thing because we want to get a cancellation of the units. You see, we want to get the miles to cancel with one another so that when we multiply numbers, you see, or divide them or whatever we have to do, we're going to end up with some number of kilometers. That's the important thing. Now, what we want to do to figure out what goes in this numerator and denominator is refer back over to the chart. Now, I'm just going to look back over to the chart, and I'm sure you can look at the chart that you have written in your book. You don't have to look over here, but I need to look over here because I can't memorize all of these things. So I'm using the chart just as a reference. So I'll look back over here for kilometers and miles. Oh, I see that 1 mile is 1.61 kilometers. So 1 mile is 1.61 kilometers. And that's all that I need. I cancel those miles, and I have 55 times 1.61, and the result of that is 88.55, and it's kilometers. Now, to be technically correct, I should put approximately equal on all of these because the conversions are approximations rounded to some degree of accuracy. So these technically should be approximately equal to. If I put an equal sign somewhere along the way, just understand that it ought to be approximately equal to. All right, let's convert 60 feet per second to some number of meters per second. Now, notice that the per second idea is in both of these. So all we're really doing is converting the numerators of these fractions. So we want to convert 60 feet into so many meters, and then the per second idea just kind of tags along. So we don't have to worry about that in terms of our conversion rate. All right, here's what I mean. If we want to, we're converting the 60 feet, and I'm just going to go right into the conversion here by multiplying it 60 feet times a fraction which has feet in the denominator for cancellation purposes, and we're converting into meters, so we want meters in the numerator. And that's what you look for, and that's what you set up as you look up the conversion factor. All right, I'm going to look over to the left at some factor having to do with meters and feet. And I see one. It says 1 meter is 3.28 feet. Well, notice the number here is in the denominator. The feet are going to cancel. And as we multiply straight across, and remember this is understood to be over 1, so what we'll have here is 60 over 3.28 meters. You see, that's the idea. And this is the calculation that needs to be performed. And once we perform that calculation, we find it to be, and again, I shouldn't use an equal sign, it's approximately equal to, all of this is approximately equal to 18.29 meters. Now, I have converted the feet into meters, and I'm converting this 60 feet per second into meters per second, so then I'll write this as, or the answer to the problem as, 18.29 meters per second. Here's another. Gasoline costs $1.59 per gallon. Find the cost per liter. Now, cost per liter. Now, the per puts that liter idea into the denominator. Now, if there's any challenging thing about all of these conversions, it's to recognize when we need to retain the units in our conversion and when we don't. In the last problem, when we were talking about feet per second and meters per second, the per second was in both denominators, so we didn't have to worry about it. It just kind of tagged along. Here we have denominators of, we have a denominator of some cost per gallon. You see, it's this. It's $1.59 per gallon, and I'm going to distinctly show the fraction like this with a horizontal fraction bar. I think it'll help us in the process. And we want to change this into some unknown cost per liter. You see, so that's the idea. Now, so we're going to take this then, and we're going to multiply it times some conversion factor. That is, we're taking this. All right. We want to multiply times some fraction that will equal, you see, some liters, some number of liters, excuse me, some amount of money per liter. You see, that's how we want to fill it in. And so we're multiplying by this conversion rate, and in this conversion rate, we need to have a cancellation with our gallons. So we're going to put gallons up here and liters down here, so that when we get this cancellation, and when we multiply straight across, you see, we get liters in the denominator. That's the idea. All right, so we set up the structure for all of this, and now we just look up the relationship between gallons and liters. And I'm just glancing over to the left, and I see that, well, let's see, 1 gallon is 3.79 liters. So 1 gallon is 3.79 liters. And now I go through the multiplication process, the gallons cancel, and I have 1.59 over 3.79. So what's really happening is this. Now we can see it right here, but to emphasize it, it's 1.59 over 3.79, you see. And dividing here, this quotient is going into that numerator. And that quotient turns out to be 42 cents. And when we put that quotient up there, the liter idea, that's 42 cents for 1 liter, you see. And I know that I have 3.79 here, but I kind of move that up into the numerator as a quotient by performing this division. And the whole purpose of this is to be able to write this as 42 cents per liter, kind of like that. You see, so we kind of go into this well-structured, algebraic-looking form, and we come back into this more practical form that we started with up here. All right, let's go through another one. Express 30 miles per hour in terms of kilometers per hour. Now, notice the hours in both denominators, so we don't really have to worry about the denominator of hours. What we have to be concerned about is changing 30 miles into so many kilometers. That's what the essence of the problem. So 30 miles times conversion factor. Now, in our conversion factor, we want to be able to cancel out the miles, and we want to be left with kilometers. You see, so now we want a relationship between miles and kilometers. I look back over there. I think I used it a little earlier. 1 mile is 1.61 kilometers. So 1 mile is 1.61 kilometers like this. These cancel, and I multiply straight across. And this is fairly straightforward. 30 times 1.61 is 48.3. And it's kilometers. So now when I change into kilometers per hour, 30 miles per hour corresponds with 48.3 kilometers per hour. In the problem so far, we have been converting from U.S. customary units into metric units. Now let's convert the other way. Let's go from metric units to U.S. customary. Here we're asked to convert 200 meters to feet. And to do that, we're thinking about, well, let's see, we want to take this 200 meters and multiply times some conversion rate. And that conversion rate is structured with meters in the denominator for this cancellation opportunity, and then feet in the numerator, because that's what we want to get to up here. And I'm looking back over to the conversion factors, and I see that 1 meter is 3.28 feet. So 1 meter is 3.28 feet. These cancel as expected. Then 200 times 3.28 is approximately 656, and notice that it's feet. So that's our conversion. Here's one where we have to look carefully at the fractions involved. We're converting 90 kilometers per hour into miles per hour. Now, this per hour and per hour business on both of these means that we don't have to worry about those denominators of these implied fractions. All we need to do is worry about converting 90 kilometers into some number of miles, and the per hour business will take care of itself. So we have 90 kilometers that we are changing into some number of miles. So the conversion rate is kilometers in the denominator and miles in the numerator. And that's what we're looking for when we look over here. We're looking for that miles-kilometer relationship. I'm looking back over there, and I see that we have 1 mile is 1.61 kilometers. So 1 mile is 1.61 kilometers, and so the kilometers cancel here, the kilometer units cancel, and I have 90 times 1 mile over 1.61. And what this leads to is 90 over 1.61 miles, you see. And now we perform this calculation and find it to be 55.90 miles per hour as the approximation of 90 kilometers per hour. Here's another one. Gasoline costs so much per liter, and we want to find out how much that is per gallon. Now, here's that tricky one where we do have to pay some attention to these denominators, and here's the way we're thinking about it. We have some amount of money in the numerator, and in the denominator we have per liter. This is for 1 liter. And we are multiplying by something, some conversion business, to give us an amount which is approximately some amount of money per gallon. All right, so that's the idea. Now, we're in this factor, we have to have a situation where we have a liter in the numerator for the cancellation here, and the gallon business in the denominator. And I'm looking back over there for the relationship between the gallons and liters, and I see that, let's see, 1 gallon is 3.79 liters, so 1 gallon is 3.79 liters. And now the liter units cancel as expected, and I'm just multiplying in this numerator, and look how nice this comes out. The 0.392 times the 3.79 is 1.49. So that's 1.49 gallons, excuse me, $1.49 per gallon. And we would probably write it with a slash like this when we express it as an answer. A backpack tent weighs 2.1 kilograms. Find its weight in pounds. Well, let's see, kilograms to pounds. So we have 2.1 kilograms times some conversion rate, which has kilograms in the denominator for cancellation purposes, and pounds in the numerator. So I look back over for the pounds-kilogram relationship, and I see that, let's see, 1 kilogram is 2.2 pounds. So 1 kilogram is 2.2 pounds. Now the kilogram, remember this is over 1, so the kilogram units cancel, and I'm just multiplying straight across then to find, let's see, 2.1 times 2.2 turns out to be, and I'll put approximately 4.62 pounds for the conversion.